Okay. Good morning. We are going to do warm-ups number 1 and 3 today. And these are review topics from December, which I'm sure that you have forgotten. So you can pretend like you've never seen these before. Okay, number 1 says find BC. And for BC, I'm just going to put a little X over there so that I have a variable to use. I'm going to put my arrows in. So 18 degrees is across from the X. And 54 degrees is across from the 34. So put your little arrows in. Anybody remember what to do? What is it called? Yes? Law of sines. Beautiful. Okay. So I'm going to start with the 54. Sine 54 degrees over the side across equals sine of 18 degrees over the side across. Okay, and now we cross multiply. So I'm going to start with these two because of the X. So X times sine 54 equals 34 times sine 18. So again, I cross multiplied my proportion. And now divide both sides by sine 54 to get X by itself. And then I don't know if my other students told you guys that I have some really goofy things that I say. Did they tell you? No one told you? Okay, well, I have like, I don't know, certain things that I like on TV. And there's this one comedian who has this comedian bit about one fell swoop. Have you ever heard about the one fell swoop bit of comedy? Okay, if you're bored later at home, just type it in like one fell swoop comedy, and it's this guy like talking about how his wife doesn't know what one fell swoop means. It's really funny, I promise. But what I say is type this in your calculator in one fell swoop, which means type it all in at once. And my battery is dying because I just let it sit here over break. Cool, cool, cool. Okay, so 34 times sine 18 divided by sine 54. Does that make sense when I mean type it in all at once? Okay. And I got 12.98. So we're going to round that to 13.0. So X equals 13.0. Okay. So there's your review of law of sines. Okay. Now this one also says find BC. So I'm going to put an X here. And this one, I'm not able to set up a proportion with my arrows. This is side, angle, side, side, angle, side. What do I do when it's side, angle, side? Law of cosines. Okay, and law of cosines is very specific. So take the angle that they give you and put an arrow across to your X. And the arrow helps you decide what goes in front of the equation. So it goes like this. A squared equals, in this case, it's X because it's across from the angle, equals one of the sides squared plus the other side squared minus 2 times the first side times the second side cosine of the angle between. Okay, so the side across from the angle squared equals one of the sides squared plus the other side squared minus 2 times the first side times the second side cosine of the angle between. And again, type this all in one fell swoop. And I got this. Okay, now I'm going to follow the same procedure for all of these. I'm going to round on my paper, but not in the calculator. So I'm too lazy to write the whole number out on my paper, so I'm going to round here. But here, I'm going to do the square root of both sides, but I'm going to do the square root of this. Okay, the square root is located right above the x squared. So go second x squared. And then scroll up with your keypad until this number is highlighted, and then you could hit enter and it will copy and paste it for you below. And I got 33.5. Okay. All right, scooch this off to the side, but don't put it away. We are going to be working on a resource page in there in a couple of minutes, but not yet. Grab your notebook. Okay, and go ahead and set this problem up in your notebook. Okay. All right, so we're gonna start with something pretty easy, but I want to talk about like what this chapter is about real quick before we just jump right in. So you guys last year did a lot of work with parabolas, right? Super, super familiar with parabolas. You know all the things about all the parabolas. Okay, and chapter 2, we started working on cubics. You guys know what cubics look like? You have a hazy image in your mind of what a cubic might look like? It goes like this. It goes like, okay. This chapter is about what happens when you get the fourth power and the fifth power and the sixth power and the seventh power. And so there's basically like a lot of loopy-loop graphs. Like, kind of wavy style graphs. There's a lot of background that you need to start, a lot of things you already know. I'm going to go back to parabolas for a lot of this to just kind of, activate your prior knowledge basically. But we're going to start with some algebra here. And first thing I want to tell you is that this is called factored form. Okay, so go ahead and make that note that this particular problem is in factored form. Does anybody know why it makes sense to call this factored form? I will accept 2 intelligent answers for that. Poor child. Okay. All right. So factor form, why does it make sense? I'll accept 2 intelligent answers. No one? I highly doubt that. You're probably overthinking it. Or you're just not going to say it because Mrs. Talbot is new to you. Okay, the 2 intelligent answers are, first, somebody already factored it for you. Doesn't it look factored? Yeah. And what does factored mean? It means you can easily see the factors. What are factors? Stuff that's multiplied together. Okay. So, factored form, we like. It's easier. Standard form is more difficult, and that's what we're going to work on in a moment. Okay, so we're going to take this equation, which is in factored form, and we're going to change it to standard form. Are you ready? Okay, to change it to standard form, we need to multiply all of these things out. I'm going to start with this bit here. So if you're a visual person like me, make yourself a little arrow to what you're going to be working on. So I'm going to multiply this part out first. X minus 2, x minus 2. Why do I have 2 of those? Yeah, because it's square. Okay. X squared negative 2x, negative 2x, and 4. Okay, now I'm going to combine like terms when I rewrite it. So this part will be combined. So now I have y equals x. And then this bit with my squiggly underline has turned into x squared minus 4x plus 4. And then I have x minus 3 still on the end. Did you guys follow what I did? So x is here. This bit is multiplied out here. And this went here. Okay, now I'm going to do a 2 by 3 box to multiply this part. Okay, and just for space saving, I'm going to put my answer over here. So I have y equals, x is still there. Combine like terms. X cubed minus 7x squared plus 16x minus 12. Does that look right to everybody? Okay. And then the last step is to distribute the x. And this is called standard form. What makes it standard form? You notice how the exponents go from greatest to least? So that's how you can tell it's in standard form. Or you can think of it as it's all multiplied out. It's tedious, but I don't know. Is it okay? You guys good with the factor form, standard form? Even though you probably don't love it, but you could do it if you had to. Okay, now let's do the definitions up here. So this is the last bit for number 1. X-intercepts, roots, zeros, solutions, factors, and degree. Okay, and you know all of these things. You probably don't know that you know them, but you do. Degree is the only thing I really need to make sure to teach you as we go through the rest of this lesson. Degree is like the most important. Okay, we're going to start with factors. I know it's weird because it's the third thing down, but we're going to start with factors. My factors are x minus 2 squared, and x minus 3. Do you guys know where I got those from? Okay, and if you want to, you can think of factors as parentheses. What's in the parentheses? Okay, roots, zeros, solutions. So we're going to go backwards to that. This is after the zero product property. So this would be x equals 0. This would be x equals positive 2. And this would be, and by the way, we call this a double, and I'll get to that in a minute. It's a double because there's 2 of them because of the squared. And this is x equals positive 3. Do you guys know where I got those from? Zero product property, like when you diamond and box and then your answer. Okay, those are roots, zeros, or solutions. So you can use all 3 of those words for the same thing interchangeably. X-intercepts is very specific. Those are coordinates. This is 0, 0, 2, 0, and 3, 0. You see how all 3 of these things are kind of the same answer? It's just how they're asking it. So when they ask you for factors, they're asking for parentheses. When they're asking for roots, zeros, or solutions, they're asking what x equals. And when they're asking for x-intercepts, they're asking for coordinates. Okay, last thing is degree, and this is the most important. The degree is the largest exponent in the problem. So this one is degree 4. Why do we care about the degree? The degree determines the shape. Do you know how, like, with a parabola, you have like x squared plus 2x plus 5 or something, and the 2x doesn't really change the fact that it's a parabola? You know what I mean? It's there, it makes it steeper or wider, but it doesn't make it any less of a parabola. That exponent, the highest exponent, determines the shape. So you can tell this one is degree 4, that's going to be a very specific shape. But how do we get degree 4 from factored form? I showed you how to get it from standard form, but I don't want to do all that multiplying out if Mrs. Talbot doesn't ask me to. How can I find the degree 4 from the original problem? What I do is I go back and I count the x's. Okay, so in factored form, here's 1x. Here's 2 x's. Why are there 2 of them here? Because it's squared. And here's 1. So that means I can tell that it's degree 4 from factored form also, just by counting how many x's are in my factors. Okay, are there any questions about vocab before we move on to the resource page? Okay, can you guys find the resource page that says 8-2 polynomial investigation? Okay, and on this problem, there's a lot of different ones. We're going to do 3 of them, 4 of them together. And then the rest of them, I'm going to have you work on in your groups on Desmos to finish them. These are not supposed to take very long. They're supposed to just be sketches. So they don't need to be perfect. Okay, let's go slow here first. Number 1, is this in factored form or standard form? Factored form. How many x's are there in the factors? 3. 1, 2, 3. That means it's degree 3. I don't need to multiply it out to determine that. That would be way too much work. Okay, what are the roots? The roots are the switched signs of each of the factors. For this one, it's x equals 2. And for this one, it's x equals -5 double. And that's kind of what the investigation is about. It's about, what does a double root do? What does this look like? What's happening here? Okay, any questions about that bit so far? You guys good? Okay, so now I'm going to go to Desmos. Kinda. I'm going to definitely go to Desmos in a second, after I fix my computer, because it's definitely first day back from break problems. Okay. All right, it was x minus 2, x plus 5 squared. And I'm going to zoom out kind of a lot so you can see the shape of it. I want you guys, when you do these graphs, to just make them sketches. I do not want you to care about the depth of the loops. I just want them to look kind of like the picture. Okay, so first thing we're gonna do is go back and graph -5, 0, and 2, 0. So I take my roots. X is -5. X is 2. Good so far. Okay, then I'm gonna go back to the picture and I'm just gonna do my best to sketch this in. So it's coming from the bottom and then it goes down and comes back up through 2. Again, I don't care about how deep this goes. Notice there are no marks on the y-axis and I don't want you to put any there. This is just a sketch. Okay, last thing. I want you to, second to last thing on this problem. Do you guys see what happened at -5? This is called a bounce. I want you to think of like the graph came up and bounced off of the x-axis, and that's what happens with a double root. A double root is a bounce off of the x-axis. So it actually counts for 2. It counts for 1 as you're approaching and 1 as you're leaving. And then it goes through this. Okay, so now let's do end behavior. The left side is going down. The right side is going up. Left side is going down. Right side is going up. And that problem is done. And really should take a lot less time than that, but I was very thorough. The next one we're going to do is number 3. So scoot your paper down to number 3. Okay, factored form or standard form? Standard form. What is the degree? What do you do when it's in standard form? 4, highest exponent. What are the roots? We don't know. That's okay. We're going to do it backwards. Okay, so we're going to go to Desmos. You can use your graphing calculator. I just think that Desmos is prettier for this. X to the 4th. I don't know why it's capital. Minus 21x squared. Plus 20x. Okay. Oh goodness. This is what it looks like. It's got like one really long loop down here and one short loop here, but I'm going to zoom in so you can see the roots. There's one here, one here, one here, and one here. Okay, so underneath the root spot, right, x equals -5, x equals 0, x equals 1, x equals 4. Do you guys see where I got those from? Does everybody see where I got those from? Okay. All right, so we're going to do 2 things with this information. -5. 0, 1, and 4. Okay, and then from what I remember from the picture, this side was like a very, okay. First of all, Mrs. Talbot, you need to go through the point that you're graphing. This is why we have erasable pens. This side was like a deep loop, and this side was a shorter loop. Let me show you the picture again, just so you can see what I'm talking about. Does that make sense from what I drew? Okay. All right. End behavior, left arrow is going up, right arrow is going up, left arrow is going up, right arrow is going up, Okay, now what I'm gonna do is use this to cheat. This is an advanced skill. So if this doesn't make sense to you right now, it's totally fine, but I'm hoping that you'll like it. I'm gonna use the roots to go backwards to find factored form. The first one I'm gonna say is I noticed that there's a 0, so that means there's going to be an x in the front of my factored form. So that's this one. And then this one will be x plus 5 because you switch the sign. This one will be x minus 1. And this one will be x minus 4. So I basically used Desmos to cheat and factor for me. We like cheating. It's not really cheating. It's using our tool. Okay. Move on to number 4. Okay, number 4. I want you to notice a couple of things about number 4. It's got an A value in the front. Do you guys remember what an A value does? It makes it steeper or wider. Remember? Okay, and this one's got a fraction A value, so that means that it's making it wider. Anyway, okay. What degree is this? The A value does not count in the degree. There's no X there. So 1, 2, 3, 4, 5, degree 5. Okay, here's a critical thinking question. If I multiplied this out into standard form, which I'm not going to do, what would be the highest exponent in this problem? 5. It would be x to the 5th. Okay, what are the roots? X equals -3. That one's a double, so that means that there should be a bounce at -3. X equals -1. X equals +1. And x equals 5. What was it? X minus 1, x minus 5? Ooh, look at this guy. Okay, so -3, -1, 1, 5. -3, -1, 1, 2, 5. Okay, so it comes down and bounces at -3. That's not shocking. That's what a double root does. Goes up a little bit, then comes down a little bit steeper, then goes up a lot, and then comes back down through 5. Okay, this is not my best work. That's okay. Okay, left arrow is going up, right arrow is going down, left arrow is going up, right arrow is going down, and I want you to label this bounce just so you can see that double root and what happened there. Okay, I want to stop here and give you some foreshadowing for the rest of the chapter. What degree is this problem? 5. Okay, watch this. 1, 2, 3, 4, 5. Okay, what degree is this? 4. 1, 2, 3, 4. Okay, we're going to do one more, which is number 5, and then I'm going to turn you loose to finish that. And you can use your graphing calculator if you would rather instead of Desmos. I don't care. Either way is fine. Okay. Factored form. What's the degree of this problem? 1, 2, 3, 4. So there's 1x there and 3x is there because of the cubed, so it's degree 4. Okay, roots. This is very important. This is just a plain x. The a value does not affect the roots. So this is x equals 0 and x equals -4. And this is called a triple root. Okay, so we need to figure out, what does a triple root do? So go ahead and graph in your roots of 0 and -4. Ah, look at this thing. Okay, so you're going to come up from the bottom and you're going to make a flat part at x equals -4, then go up and then come back down through 0. We actually learned the vocab word for this back in chapter 2. Does anybody remember what that is called when it does a swiggle like that? I'll give you a hint. It starts with an I. Yeah. And ends with inflection point. It's called an inflection point. Do you guys remember? They're on the cubics. And why would that make sense? Because that root is a triple, which is a cubic. Okay. Left arrow is going down, right arrow is going down, left arrow down, right arrow down. Okay. Do you guys know how to find what the homework is? It's 4 CPM problems. Do you know where to locate that information? Front of the packet. Just to let you know, slight procedural change. I will be stamping your packet, not your notebook. I like to see all the stamps. It's fun and satisfying for me to have all the stamps lining up. So just so you know, when you come in, I'll be stamping your packet, not your notebook. Okay. So finish up the rest of these graphs in your groups and then start working on the homework if you have time.